Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode of the Chai Time Data Science Show. This is a very first, if I may, on the series where I get to interview two amazing Kagglers. I'm sure they need no introduction. Dmitry Gordeev, also known as dott, D-O-T-T on Kaggle, and Philipp Singer, P-S-I on Kaggle. I've already been lucky enough to interview Philipp on the series, so please do check that interview out if you haven't. In this interview, we talk about first Dimitri's journey into data science and Kaggle, and in the later half about the zoo. Dmitry and Philipp's team name for all of their amazing victories has been unanimous. I'm sure now with the community, it's known as the zoo. And we talk all about the zoo's journey, both of their journey on Kaggle together, their approach on teaming up, their approach about winning a competition, and we discuss definitely about what does it really take to win a Kaggle competition. The zoo in the past 1 year has had 100% success rate of medaling, including 3 wins on competition. By wins, I mean first position finishes and a large majority of gold medals. We also talk about their recent win on the NFL Big Data Bowl competition, their approach to the competition, of course, zooming out and talking about how they went about distributing their workloads. What does it take to win a competition? How does their approach vary over the days of the competition and their solution? A quick note to the non-native English-speaking audience. If you're watching this on YouTube, or if you're not watching this on YouTube, please go to YouTube and enable the subtitles, because this will have manually checked and re-uploaded subtitles so that you all can have a better watching experience. The written version of this will come out in a few days from the release. So you can also find the links to where the written or the blog version of this interview will come out if you'd like to check that out instead of watching or listening. For now, here's my interview with the two lions from the zoo team on Kaggle, Dmitry Gordeev and Philipp Singer, all about winning Kaggle competition. What does it really take to win a Kaggle competition, the zoo, and their solution about NFL Big Data Bowl. Please enjoy the show. Hi everyone, this is really a first time for me. I'm sitting across two lions in the call, two lions from the Kaggle Team Zoo. Dr. Philipp Singer, who's on the show for the second time, welcome back, and Dmitry Gordeev. Thank you so much for joining me both on this series.
Thank you, Sanyam, for having me a second time. Great honor.
Thank you for having me for the first time then.
Privileged to have you. If you could just speak out your names for the audience who tune in through the audio so that they can recognize you by your voice.
Philipp.
And Dmitry Gordeev, that's me.
Okay, awesome. Now, since the audience is already familiar with Philipp's background, I'd like to go for a first solo goal discussion, pun intended, with the dott, Dmitry. I believe your background is in pattern recognition. You studied pattern recognition at Moscow State University. Can you tell us more about it? And can we call it data science today? Because I think that was a little while ago when they called it pattern recognition.
That's true. I think in Russia, the education system is a little bit different, and therefore the naming convention of certain things were different. Back then, that was the faculty of computational mathematics, and we had also an interesting name for exactly the specific the courses, the part of the faculty I took. But translating to more commonly known terms, I would say machine learning, data mining, this sort of things. So I would probably not be completely wrong by saying that I have a data mining master degree from Moscow State University, like trying to connect the terms with the usual system of naming the educations.
You were way ahead of the curve. You studied this in 2005 when even AlexNet boom, all of the computer vision boom hadn't happened. And I believe you also studied computer vision. Did you have a passion for this field then, or did you start in data science later on in your life?
With computer vision, I started quite a while later because back then, I think it was rather like the beginning of competitive machine learning.
Okay.
So we had lots of theoretical background there with regards to the algorithms, what was out there. We were using mainly MATLAB back during the studies. So kind of the hype of R came out a little bit later, and then Python. So I had to catch up after I graduated. One of my teachers became Kaggle top 1, I believe, a few years after I graduated. Unfortunately, he's not participating in Kaggle for a while now, but I learned quite a lot from him. So you can imagine that we had also quite a nice stress on the practical aspects of the field.
Yeah, for sure. I can only imagine. You're also currently a data scientist at Unica Group. Could you tell us what problems are you working off Kaggle, and what does a day in your life look like, along with the balance that you're maintaining with Kaggle? The winning balance that you're maintaining with Kaggle?
Unfortunately, at work, you don't have like such nice prepared tasks and problems and data sets. So by far the most part of our work, and I can say our because together with Philip, we basically we work for the same team within the same division of the same company. Most of the work is dedicated to like stuff around it. So I don't know, 90% of the work is about talking to the people, discussing the ideas of what projects to run, thinking what data to collect, talking to people, try to do the bureaucratic paperwork to get the data. And we also take over a lot of like technical stuff around it. So since we started at Unica, we also decided just to take over whatever is about like data storage, data ingestion, maintaining the cloud infrastructure, stuff like this, as well as like deploying the model, pushing them to basically we Dockerize everything, we push everything to Kubernetes and do it in the cloud. So like major part of the work is related to be capable of delivering end-to-end services and products within the company.
Okay. Now, people have this misconception that you absolutely need to know everything, a lot of things that you mentioned. Do you think your traditional background helped you knock it out of the park, or did you also have to learn a lot of things as you went along your journey?
It did help a lot. I believe I have quite a strong background in mathematics and in computer science, software development partially as well. That helped a lot. And that applies not only to machine learning specific tasks, but at the tasks around it. As I said, like the data related things, you always have to struggle through the deployment things, which is also quite a big struggle as it turns out to be. So that was really helpful. I can clearly, well, I can just looking back state that it helps quite a lot.
Okay. Now, you also had a direct influence of Kaggle from your professors you mentioned, but what led you to signing up on your first competition, and how did you get addicted to the Kaggle bug?
I had like two kind of separate journeys on Kaggle. First one was, I think around 4 years ago. I kind of discovered the platform on my own, which was not that difficult back in time. And I wanted to jump in, try things, just see how well I perform. I can do such things. Back then, I discovered that one of my professors started doing the competitions and doing quite well. I didn't know that before that. So it was a surprise to me. And I think I did 3 competitions. I did it completely alone, and one of them, I kind of set a target to get to top 10 in one of them, because back then that gave a label of master. They didn't have grandmasters back then, so
Okay.
that was a kind of a big thing for me. And that was to a large extent lucky, but I got exactly to the 10th place, jumping 2 places from the public to the private one. So it was really exciting, and it was really educational to try things there, because that was exactly the place where you can try all the state-of-the-art modern algorithms and methods. So it was really good knowledge base for me. Back then, everyone started using XGBoost. Most of the competitions were tabular, maybe some textual data. So XGBoost plus neural networks, stuff like this. I tried that. So I did 3 competitions, got 1 gold medal. That was not a gold medal according to the terms back then, but
Okay.
it is now. And then I kind of took a break, because I realized how much time it requires, how time consuming it is if you want to really succeed. And I didn't have the time. I was working for a bank here in Austria back then, and I just realized I cannot manage like everything all together, personal life, professional life, and Kaggle. So I gave up for a little bit, until 2 years ago. I just decided to leave whatever I was doing back there in banking and just focus on data science as the field. I was able to get a position of data scientist in an insurance company, and then the whole story on Kaggle began around a year ago.
Okay. I think you both have discovered a cheat code to Kaggle. Whenever you name your team to the zoo, you'll probably end up in a gold medal or winning the competition. Is that your secret? Because I was going through your profile, you have 100% rate of medaling with a 70% rate of gold medaling, which to my knowledge is the highest. Can you share a little secret of yours?
Maybe it is indeed the name. We don't know it yet. We might try a different one. Maybe it doesn't work if we rename ourselves somehow differently. Yeah, the most success, of course, is coming from the period where we teamed up with Philipp and did a teamwork. We had, I think we're in 7 competitions. Yeah, I posted it about it on Twitter. I think we had 7 competitions, and to me, it was amazing how well it worked. So I felt like it is a good time to just state the achievement, because it cannot last for too long. I'm sure the next couple of competitions we're definitely not going to win and might not get to the gold. So let's just enjoy the moment for now.
I think it will be otherwise, but coming back to your team, I remember Philipp got really mad at, I think you got really mad at Philipp one time because you didn't name his team to the zoo. So I figure that's the cheat code again.
Absolutely. I got really upset because you have to, was it the one competition where we didn't get the gold medal? Maybe that was the reason why we didn't get it. But yeah, we decided to keep the name, just well, to have some sort of a label of our team. Why not? It's brought us luck, apparently.
I think it's you hold the right to it, so that Philipp can't go solo naming himself to the zoo and become a grandmaster like you already are.
Yeah.
Fair enough. Well, maybe he needs to have this name on his profile for a bit to get his solo gold.
Now, actually, sorry to jump in. Actually, I tried to do it, and Dmitry told me not to do it. So maybe I should do it. It might bring actually luck. Yeah.
Yeah. I'll close my eyes. You should rename it just a few minutes before the deadline of the next competition, and just let's see what happens.
Now, coming to your teaming up strategy, I'm sure teaming up on Kaggle would have affected your professional life as well. As you mentioned, you both team up on work. Can you both speak to how did teaming up on Kaggle affect your professional life, teaming up in real world?
Okay, I can start. Well, I mean, first of all, I think I mentioned that also last time. In teaming, you learn a lot, and probably you learn more how the other person works than if you're in a project at work, because as Dmitry said, there are so many different facets to it at work. But on Kaggle, you focus on one thing and one goal, and you try to achieve that goal together. So you can have more a streamlined process towards it, and you can kind of also see how the other person works. And of course, it enables you to also learn to trust the other person, and to see that you can rely the other person. And I mean, the more and more you work together, I can fully believe in his capabilities to do anything. So that's of course also quite fruitful for the off-Kaggle work, I would say.
Awesome. Now coming to your partnership on Kaggle, how has it evolved over the years? Have you learned up? How do you fit better into each other's puzzles? Your skills, I believe, they might complement each other, or is it still a natural process? You both pick up tasks as you see fit for the competition.
Since the very beginning, we decided not to have any like segregation of duties, just because Kaggle was first of all learning experience for us. So everyone wanted to learn everything pretty much. And this is how it works since the beginning, and still the way it works. So everyone feels free to try whatever crazy ideas he has, or whatever he thinks is important at the moment. And that works quite well for us. I would say several reasons. One, because a certain idea might affect different parts of the modeling pipeline, and you may have an idea and start with like changing model parameters and end up redoing the whole data pipeline in the end. So I do believe it is not worth to like strictly split between one thing and another. It is quite fruitful to explore and just maybe go with the flow. In the meantime, the other person does the same thing. You exchange your ideas, you exchange your discoveries, and that helps. This is basically the way we approach things. So every one of us just basically feels that, I don't know, has his own list of ideas, knows and recognizes the list of the ideas of the other one, and whatever he believes in at the moment, this is the stuff he focuses on.
Okay. Now, how does this approach change towards the last days of the week, especially in hindsight for the competition that you have won? I think you have won 3 competitions together. Is there any change, maybe a bigger push during the last days?
So I guess how we change our collaboration during the last days of a competition depends very much on when we start the competition. So if it's very in the early days of the competition, like for example, it was in NFL where we started on the first day, we, in best case, as it was this time, we already have a very, very clear plan. And in this case, we also had like perfect cross-validation, perfect everything figured out. So it was just fine tuning in the end and praying that no one catches up to us. So mostly holding hands and praying. But of course, it depends on other competitions where we start later and where there's still a lot of stress in the end. There's always stress, but in terms of figuring things out, you haven't figured out everything, you try to improve. So then of course, we try to maybe split it up a bit more, like one does blending, the other guy does more on the feature engineering or the modeling side.
It's like this show in the games, one commander takes position of one border and the other commander is doing other stuff. Is that the case?
Exactly. But we still try to always push our ideas and our insights. So we really try to not do it alone. Like one can physically do it alone, but it's more than doing the coding part. It's more
the brainstorming is together.
The brainstorming is always together, like chat a lot, talk a lot, and yeah, I mean, over the time, as we have worked so much together, I mean, some of our ideas converge more to similar ideas. Because in the beginning, like we had more like some competing theories. Like for example, early stopping is something where we have always discussed and still discuss. and also discuss with other people. Like that's one of the main things we always in each competition. Should we do early stopping? Should we not do early stopping? But now we both don't like it any longer. So yeah. But still, it's very important to, as Dmitry said, have crazy ideas. I think that's one of the main things. Like you need to have something in a competition to have an edge, and that usually needs to be some kind of crazy idea. And yeah, so also if it's still on the last day a crazy idea, you can still try it out. Yeah.
Yeah. But we usually focus on a single competition. So instead of like trying 2-3 different ones in parallel, we usually take one and focus on it. So by the time it is like 2-3 days before the deadline, usually I personally feel exhausted from thinking about the same thing over and over again. So I do believe I tried all the ideas which could have popped up in my head by then. And the last days is about picking the last submits, deciding on certain minor things, and yeah, holding fingers crossed that no one catches up.
Yeah, I mean, you can even have a very solid solution, and in the last few days destroy that solid solution because you tried too much. Mm-hmm. In German, I have it lately with my German pronouns, but it's called like verschlimmbessern. So you make something that is already good worse. And you need to be careful there to not overdo it. So, but of course, you still try in the end. And if the leaderboard is tight, you try some things. But then in the end, you need to select your 2 subs. And of course, that's also one of the main parts of the competition. That's why we also talk a lot about that then in the last few days to come up with something robust. We usually start blending earlier than others, I guess. So we already have a plan how to blend. But of course, in the end, you need to then decide on the final blending, stacking, not blending, and those things that hopefully give you an edge on the private leaderboard.
On the flip side, I believe you both are at a stage where you can keep coming up with new ideas. For some noob like me who gets stuck on the leaderboard by just copy and forking, how do we, or any suggestions for how do these noobs come up with new ideas? How do they keep progressing on the leaderboard?
It's a tough question because usually what we observe is we have always a good backlog of ideas. Usually we start with those which make the most sense. Of course, they take the first couple of weeks, but still, like, let's try this, or oh, I saw that sometimes this stuff works, or let's try what we did in the past competition, or let's try what someone else did in the winner's solution. And we saw it in the winner's solution of a competition which took place, I don't know, 2-3 years ago. Though there is a paper where someone tried something like this. And they usually, we are not that fast in trying those ideas out. So they usually, the list is, as always has like 5-6 ideas there. So you start the Kaggle kernel, you're like, okay, we have like 5 ideas, let me try one or 2. They usually fail. As soon as they fail, you start thinking in different direction, write down another idea, put it there, and so on. So usually there is something there. And as soon as we don't limit our scopes to certain parts of the pipeline, it is quite easy to jump from one thing to another. So you spend 2 days trying to optimize the structure of the neural network. You get tired of it. You're like, okay, let's just, I don't know, do something crazy with the data. You switch to the data and maybe it helps, and you like start thinking a little bit differently because you haven't thought about it for a while already, and new ideas. But like 1-2 months, and then you get really tired of doing the same task, doing the same problem.
How do you track these experiments internally? Do you follow best coding practices? I'm sure you both must be familiar with each other's coding style. Maybe you're doing code reviews internally at work also, or do you try to avoid that? Because like you said, you put an idea on the freezer and then come back to it.
I think that's one thing we try to optimize more and more. So Dmitry had the idea to start also storing snippets of code somewhere so that we can reuse it. So we have started to do that. I think both of us have a quite solid, clean coding style. So that kind of usually fits together. Of course, each one codes a bit differently. But what we usually try is that one writes a starting kernel, starting notebook with the main pipeline, and then we usually work together on that one. So our codes are basically comparable and usable. I don't think we do any official coding style or anything, because we don't have to, but maybe it would be a good idea. But in general, I think we have quite a solid code base. And tracking, we use an Excel sheet mostly for experiment tracking. So nothing too exciting. We were trying with other tools, but Excel sheet usually works quite well, to be honest, because you have a Google sheet and everyone can just enter the scores and you can track it. And discussing CV and correlation to LB is very important, so that's what we do a lot, of course, and that's why we need some kind of tracking to do that.
We prefer to do even kernel competitions for multiple reasons, but it also forces us to follow some standards of the coding, because as soon as you know that the other person is going to fork your kernel if it works, you stop doing like dirty things, quick and dirty solutions. It adds a little bit of discipline in the end, but it also makes you makes it a habit, I would say. After you do it for a little bit, you're like, okay, I'm never doing like this quick and dirty, awful code, inefficient calculations sort of things. Even if you want to have a very quick check of a certain idea, you still do it in the proper way.
I think, for example, in some competitions, you just have to do the inference in kernels, and you can do the training externally.
Yep.
And what I think is a good idea is to start on the kernel first, have a baseline kernel there, then go to your offline stuff, because it's very hard sometimes to port your offline solution to the kernel solution because of memory issues, this and that. And at least if you start working on the environment, you have to do the final data preparation and everything, it can help you. And I guess also sometimes it's very tempting and easy to start with a public kernel, but I guess it's really advisable to start with your own, from scratch with your own kernel, because first of all, it lets you understand the public solution way better, and it lets you figure out if there are any problems in the public kernel, and you start with something clean, and you can have your own inference. Because if you start with a public kernel, those have sometimes bugs in it, so it's I think a good way to start yourself.
Now talking about, you were just mentioning you have to discuss all of these ideas, I believe, and Philip also mentioned this on the earlier interview, that teaming up is definitely a lot of fun. The zoo has brought in a lot of amazing legendary teaming up also. I think you've teamed up with Christoph Jiba as well. Can you speak about that experience? How does teaming across different time zones change? Because for now you both, I think, can sit down and discuss ideas. How does that change in that scenario?
That was kind of part of the learning curve, also to team up with others and see how they work, see what we might miss from the way we do things. Giba was, I think, the first person we teamed up with, probably. So it was a good learning curve for us to see how he approaches tasks, because, well, I knew Giba even from the times where I just started few years ago. He was by far top one there, and that was also an interesting thing to a little bit maybe learn how he approaches things, how he thinks about problems, how he comes up with the idea. Also, like technically, how does he collect the models for stacking, stuff like this. So it was part of the experience, I would say, part of the Kaggle experience to team up with different people to see how things work on their side. What do they prefer to do to learn from them?
Okay. Shameless plug. I've already interviewed Jiba on the series, so you can find a link to that interview in this description. Please check it out if you're curious. Now, congratulations on another gold medal. In fact, another win in the NFL Big Data Bowl competition. Before we talk about your win, I'm sure there are many more to come. Can you set the stage by telling the audience what was the challenge here and what led you to joining the competition in the first days? Usually, is it like you see the CSV manually and numbers start popping around your head, you figure out you will win this? Is that the case with your expertise now?
So let me start with quickly giving an overview of what the competition was about. So NFL is American football. So they play with a ball. You can call it an egg, and they have to carry that egg to the end. That's what we had to learn. Anyways, so they have a lot. They have a lot of tracking data. So they have some sensors for each player, and they collect the position, and by the position they can also deduce things like speed, acceleration. They have also orientation, direction they're looking at, and they are collecting this over frames. So certain time span between frames, and they collect it for each frame. And the teams have that kind of data, and that is tracking data. And what was the task in this competition was that there is a situation where the rusher gets the ball by the quarterback, and he has to rush forward, meaning running, and that's called a rushing play. And we had to predict how far is the person rushing forward, so how many yards. And we had the data exactly in the frame or at the time of handoff, so as he got the ball. They can detect that basically from the whole tracking data, but they only then selected that data at that point in time, and that's what we had. So at the time of handoff, we had all the data of all the defensive players, of all the offensive players, for each player their respective position, speed, etc. And we knew how far did the rusher run. And then we had to use that information to predict how far he is running, basically. Why did we join? I don't think there is a specific reason. We jumped in really early in that competition. I guess both of us are sports fans. We definitely were not NFL fans before. But
were you familiar with all of these terms that you just mentioned, or
no? Like no. I mean, for example, I was once at the college football game in the US when I was visiting there, so I know roughly how it works, but we didn't know any details, like what is a rushing play, even we didn't know that, or what is a punt, what are all these things, what is the role of each player in a play. So we watched videos, we watched the data, we checked the data to figure those things out. We're still not experts, but we understand it way better now than before. So coming back to why we joined, we were sports fans. It looked like very interesting data, like tracking data. It was a kernel competition. There was hopefully no potential for a leak, which was the case because it was scored on future data. And we were just kind of ready to jump into something new. So that's why we jumped into.
Yeah, that was exactly the period when Kaggle hosted, I want to say 8 to 10 image competitions at the same time. So it was like heavy deep learning, and we also tried to jump into this game. We took part in one of the computer vision competitions, and we finished that one and the next one, and the new limitations on the GPU kernels kicked in. So basically that was the moment when there were a lot of computer vision contests with huge data sets. And I personally don't have a GPU at home. So basically I was always relying on GPU kernels on Kaggle. So I had no chance to jump in. Philipp got his GPU only after winning Quora. He invested in getting a good computer at home. I didn't.
For tax purposes.
Yeah. We all know the story. And at that point, basically, we're just sitting and waiting for something next to happen. And the first thing that popped up was exactly NFL competition. So we tried it. We looked at it for a couple of days. We got really into it quickly, I think within a week, and then we just continued. So that was the reason why we started it early, and that was one of the reasons why we jumped into NFL competition.
I think this also speaks to the sentiment. If you're not a domain expert, you can also, using your expertise of data science, if I may, pick up the field and also get a better knowledge. And you've already won the competition, but I'm sure you also learned a lot about NFL also, so to speak.
Absolutely.
Yeah, I mean, we can go a bit about that maybe when we talk about the solution. But in general, I think anyone can win any competition mostly, except maybe very computational heavy solutions. So competition. So you can come up with something novel and new without necessarily being a domain expert.
Now, speaking about this competition specifically, I think usually Philip had mentioned this, you like to join the competition slightly during the later days. How was this different? How did the workflow starting from day one change over the years, and change over the days, and what were your go-to steps when you joined the competition?
We learned that after a few competitions, we learned that it's not a good idea to jump into one since the very beginning. First thing you need to do whenever a competition starts is just sit and wait, see what's going to happen, and then pick up. That's the advice I heard myself, and I probably agree with that. So we knew we're doing something wrong by just investing that much efforts that early in the competition, because what's most frustrating on Kaggle is getting stuck. And if you start early, if you run out of ideas early, you're stuck somewhere in the middle in the competition, and this is the most upsetting experience you can have. Everyone else catching up, and you're just slowly getting lower, not staying. People are overtaking you. You're just going lower and lower, and there's nothing you can do about it. So that even went to extreme with NFL. I think we were stacking models by the end of the first week of the competition, because we just rushed into it, put together like LightGBM, a few other models, combined them, blended them, squeezed a few digits, and got to like top places. And then we realized that basically there should be a better way to do things, and we changed the focus, and we kind of restarted the whole thing after a couple of weeks. But it was helpful because we learned the data, we learned what exactly is happening there. We learned the metric, which is a weird one. We learned how we kind of got the feeling of how sensitive it is to different types of modeling and so on.
And I think like this is the perfect example for a competition where you cannot start too late to be on the top. I think if you jump into that competition the last 2 weeks, except you know something, I think it takes, for that competition, you first need to come up with a proper model, and then there is a lot of tuning work also that needs to be done. So it's not something where you can jump in quickly, even if you have the idea, which is already hard enough to come up with. I think it needs time.
Are you still, do you both still hold the opinion you should join a competition early or late, or again, it depends on the competition for you?
Depends, but it is better to start later unless the competition is quite short. Like if you remember Lanel, how long was that? 4 or 5 months long?
5 months, I think, yeah.
5 at least. We jumped in 2 months before the end, and that was definitely sufficient.
Okay. Now coming to, and this is one of my favorite questions, because distributing workflows, since data science is such an exclusive idea, teaming up, you have to learn how to distribute your idea. Speaking of this competition specifically, how did you distribute your workflow over the days, and Was it again a natural flow, or any segregation happened?
I would say it was if not completely random, then it was changing like day to day. So someone wakes up in the morning and has a brilliant idea to rework the whole structure of neural network, or like the data preparation. So he digs in, he tries that, usually it fails. The next day, okay, let's do fine tuning of like certain parameters, and that one. And especially in the beginning, if you talk about like long-term planning of where to start, what to do, what to postpone until the later stages of the competitions, that was definitely a very bad example of what we did, because we did like the full-on day preparing the model, modeling and stacking within 2 weeks. Then we just started from scratch because we kind of got stuck and realized that's not working that well, and maybe there are like certain concepts which would fit the problem better, and they did.
Okay.
And maybe to add one thing, what is worth mentioning here is that Dmitry had one really fundamental idea in the beginning, or soon after the start of the competition, to restructure the neural network. And correct me if I'm wrong, but it didn't work the first time. But sticking to the idea, if you believe so strongly in it, it worked a little bit by changing it a little bit. So sometimes just because something doesn't work the first time, it's worth to stick to it and maybe rethink it a little bit, and also try to adapt a little bit. I mean, after we had this, it was mostly tuning and changing things to the architecture and figuring things out. But we had such a strong cross-validation setup that we could test basically every idea we had with complete confidence. Either it works or it doesn't work. So that was really, really nice in this competition.
Speaking of failed ideas in Dmitry's write-up, and Dmitry, as a fan, I request you to please do more write-ups on the forums or discussions. But in your write-up, you publicly mentioned all of the ideas that had failed. And like Philipp said, you pursued a few ideas that came through. How do you not go Control-delete when an idea doesn't work and you get frustrated? And how do you keep pursuing it?
Well, that's a key thing, because to my expectation, like 80 to 90% of the ideas we try, or overall throughout the competitions, they fail. Like maybe 1 in 5, 1 in 10 ideas would work. So it is the struggle which pays off in the end, but you have to get mentally prepared that whatever you try, there's a good chance that it fail. We have kind of an inside joke. Whenever someone comes up with an idea which makes total sense and explains it in a very straightforward way, it has all the logic behind it. These ideas usually like have 99 to 100% chance to fail.
Okay.
Yes. If I show up in the office with all shining with the great idea and claim that absolutely has to work because this and this, usually Philipp just nods along. Yeah, makes sense. Try it. You know it's gonna fail. I know he knows it fails. I know it's gonna fail, but you have to still try and learn something from that.
And I mean, overall, it's not, we don't know which idea would have worked if we would have stick to it. So, I mean, you cannot explore everything. There is only a limited thing you can explore. And an idea is like a feature of a model or of the data. So basically, sometimes the idea might only work in combination with the other idea. So it might be a combined effect that can only be achieved if you do both things, or if you also do the other thing. So it doesn't always work, but it makes sense to also come back to failed ideas a few weeks later. Like, let's say the idea is, I don't know, everyone has that idea, but pseudo tagging can work, or knowledge distillation. And maybe your model at this point is just too weak that it doesn't work properly, but it's a simple thing to try later again. or there are more complex ideas, but still also thinking how this idea might interact with other things is important. But you never know. I mean, there might be so many ideas that we think failed, but in other circumstances they might have worked perfectly. It's hard to say.
Do you think your amazing results and I'm sure efforts from earlier also factor into intuition, if I may, or any other ideas that you found useful from your previous competing experience in this competition?
Definitely. I think NFL is a good example of surprisingly the logical idea which we put together on paper ended up working in the competition. Okay. So we had an idea of how to kind of what principles to have within the neural network, and therefore what structure it should have. Tried it. I mean, I think the very first attempt failed, but like the second attempt, which we took, I don't know, 15 minutes after that by slightly reshaping it, worked well. And then we basically built everything else on top of the main principles which stood behind it, and that worked. Other than that, usually in competitions, you know things that worked previously in from different winner write-ups, from different discussions. You know, like the basic ideas, the usual suspects there, and you go through them. Sometimes some of them work, sometimes they don't. Sometimes you realize that there's some trick in it and start thinking, developing the idea or changing it, or maybe coming up with something a little bit different. But in this regard, I would say it's maybe experience over the intuition mostly. But sometimes when intuition works, I think it is even more rewarding.
Also, did you have any predefined pipelines that you could just pull in? Do you keep a record of your previous pipelines for future competitions? Do you find those useful?
I mean, in this case, we used mostly PyTorch to fit the neural network, and we have used it in the past. So we of course could reuse a lot of the code, but I think this is the first competition where we really refined our PyTorch code, and so we have to have that now ready to be reused in other competitions. And as it was a kernel competition with a very, very restrictive thing, it was, how many runtime hours was it? 4 hours, yeah, CPU only. And we used neural networks. And we had to fit in the kernel and predict in the kernel. So that already, you had to use neural networks, but you could not do them on GPU, you had to do them on CPU. So we had to work a lot on the pipeline to optimize towards that. Things like doing parallelization, using all the cores, figuring things out with NumPy and multi-threading, and figuring out that kernels use different CPUs across different runs. So there was a lot of stuff to do on the technical side to really bolster and boost our solution, because we wanted to bag as many models as possible and also run more complex models and themselves. So a lot of work went, and we had a lot of time in this competition, a lot of work went into refining that, which is good because we have that basically ready to be reused. But in general, as I said earlier, we have snippets for different things, and of course, it's also in our brain to write the code down quickly.
Yeah, we as soon as we prefer kernel competitions, we also tend to write like compact code, so shorter things. And after we finish a competition, we usually just slice it, and certain important things, they just go to kind of a snippet storage, and then this is what I personally use to start new ones. So okay, if I think PyTorch would do here, I just copy over some snippet from a different competition and then start changing things. So if it was a classification task, now it's a regression, certain things to change, like the input data structure and so on. It's I think it plays a little bit of psychological role. When you do something from scratch, you try to resist it because you think it's going to take too much time. But as soon as you have a snippet of code and you just rework it, you might end up like changing pretty much everything there, but you don't have the impression that you invested that much time, because you usually don't.
Plus, since it's your code, you're already familiar with it. Many beginners struggle with I think it's a paradox of starting with something from scratch. Unless you're experienced enough, you cannot do that. But you need to do that if you're going to be ahead of the game.
Exactly.
Now, another topic that I want to touch up before we talk about your solution is beginners assume that grandmasters are these people who sleep in a room with nothing but GPUs as a heater. And you just mentioned you don't have a GPU setup. Can you speak of the hardware that you think a person would need to become a better data scientist or better machine learning modeler, if I may?
Maybe Dmitry is the better person to answer that, because I would assume the only top 10 grandmaster without a GPU at home. I believe it has two sides of the story. First of all, having limited hardware can also improve your skills, because first of all, you need to focus on simpler solutions. And you need to focus really also on your coding and efficiency and of the runtime, which can really help to shape the solution. Because sometimes it happens that you start with something very, very complex, but you completely neglect the more simpler solutions that you would do if you have more limited hardware. So for example, in this case, I believe we would have started more complex maybe if we would have had more capabilities in terms of computational power, or even more knowledge about the topic, like others started with more complex things like transformers, which we didn't even think about starting in the beginning, because we were first of all not that experienced in it, and so not blinded by it in some sense, and we tried to really start the idea from the scratch, and also from the computational runtime. The other side of the story is that there are, of course, some problems and data sets nowadays that can only be tackled, or that can be better tackled with more computational power. So there is definitely necessary. I still believe that most, like maybe 80, or let's rather say 70% of the competitions on Kaggle can be won without using the Kaggle hardware, which is the kernels.
Yeah, we need to put aside probably computer vision competitions mostly, especially with large data sets, especially like the Google competitions. They do require quite heavy hardware, and in general, computer vision is the area where more computational resources can bring a lot of benefit. So we try to focus on other things, but we also did one computer vision competition just not to have like a topic we haven't covered. We didn't use that much resources outside of Kaggle for that one as well. Not that much. We did, of course, but not that much. But with regards to all the remaining competitions we tried this year, all three we won. We basically won with the models with the runtime either within the kernel limitations or in terms of LANL. Well, it's a different story, but I think an LGB model which won the competition ran within like 20-30 minutes, something like this. NFL and Quora, they were kernel competitions, so we try to focus on those. And I agree very much with the statement that if you have like very powerful machine, you might get kind of sidetracked and focus on rather like brute forcing the task, while you should spend your time and your brain to figure out a better setup, a more efficient way to run things, or a more appropriate structure of the model and stuff like this. And this is going to beat the competitor which has just more GPUs and runs the same stuff with for longer epochs or with lower learning rate, stuff like this. And we try to focus on such competitions, and we try to avoid those which are definitely going to be kind of going to require lots of resources, or where we see that it will be a clear benefit. And here, when we saw NFL, that was a perfect example. It's a kernel competition. You have like a handful of thousands of records, and it's all about like running things in a compact form. And we also are big fans of doing everything really efficiently, and that really kicks in when you have limited runtime, when you have limited resources. So even if you have a neural network you need to fit within the CPU time limit, if you run it efficiently, you can do it pretty much the way someone else would do it in a brute force manner on GPU. It has a funny side effects. We had this 4-hour limits on CPUs for NFL, and we ran some of the cross validations on GPU machines, because in PyTorch you basically change one line of code and you're running it on GPUs. So whatever ran for 4 hours, you can just transfer it to GPU. It will run within 20 minutes, and it's still a good thing to do.
I think that's also where the distinction, again, a plug for my interview with CPMP, do check it out. But CPMP also, I think in one of the competition, or he constantly does share this optimized code where you can speed up your code by really a huge factor. I think that's also an opinion. And I wish many more beginners who are afraid of the hardware listen to this. For the computer vision competitions, I'd also like to mention that even though it's a mental barrier that you need to deal with the huge data, Google usually does sponsor some amount of credits to get you started with it. So still do it anyways. That's a message that I'd really like to get across to the audience. Now, coming to your final solution, I'll definitely have the write-up by Dmitry and hoping to read more write-ups by him, but we'll have that linked in the description. If you could please give a very high level overview of your solution.
Well, we basically write the write-ups usually together, then just flip a coin and pick the one who publishes it.
Okay.
In a way. Now with regards to NFL, it's a very long, interesting story how we came up with this idea, but yeah, which we tried to express in the write-up. What we did in the write-up, we split it first part to kind of explain why we did it this way. So forget about machine learning, let's look at the task, which was looking at the NFL play as a person who has no idea what's happening and just tries to explain to himself the things in simple words. So there is one person, ball carrier, who has the ball, and he's trying to rush towards the end of the field.
Okay.
There is the whole defensive team who are trying to tackle him and stop him as early as possible. And all his teammates are basically trying to prevent defenders to stop him. There were quite a lot of top solutions which put the players in certain order and applied transformers on top of that. So transformers were supposed to recognize what are the dependencies between the players, what is important and what is not. Everyone quite quickly understood that the most valuable variables are relative positions and relative speeds of the players, not that much wind or temperature or who exactly is carrying the ball, or I don't know, the score, the leaderboard scores, stuff like this. So some people put together like an array of the players and then did the same trick the transformers do for the word embeddings, basically, but just instead of words, we have players. What we did, we tried to split it into kind of a simpler things. Let's remove all the teammates of the ball carrier. So there's one guy with a ball and 11 guys are trying to stop him. And a key idea was not to impose any sort of arbitrary ordering or filtering of the players. So we treat all the 11 equally. And after that, it quite quickly transpires that to implement it, you just run a convolution with a kernel size of 1 over the defensive players. and then you pull them together somehow. So you treat all 11 players equally, and you don't care in which order they're supplied to the neural network. That idea shined quite quickly, and we got to the top for quite a while without using any data about the ball carrier teammates. So out of 22 players, we used the data only of 12, and we were like top 1 for quite a while, then dropped to top 2 or 3. So we realized this idea works really well. And then we applied the same idea to the offensive team players. So pick one defender, and look at all the offensive players as those people who are trying to stop him tackling the rusher. So this gives you like the idea of having like the second kind of nested convolution over defensive players, but you can nicely shape it into a tensor. We did that. We jumped back to the top with a quite nice and comfortable gap, and spent most of the time fine-tuning the structure, trying other ideas like augmentations, because why not? It's a neural network, and we don't have that much data. Let's try augmentations. We tried different things and tricks, and we had perfect CVs. So it was a brilliant competition for us in terms of how much we enjoyed it. We had one interesting idea in the beginning. It worked incredibly well. We were able to invest time to improve it further and further. We didn't have to submit to leaderboard because the correlations of CV and leaderboard were perfect. So we're just like working on the idea, progressing constantly until probably the last week.
And I mean, what is one very, very frustrating thing on Kaggle in many competitions is that you develop a model, you think it's good, you submit it to public LB, and it sucks. Yeah? So that's a very frustrating thing. Even though you should not care that much about public LB, it's still a very frustrating thing. And taking that out of the equation in this competition made it really enjoyable, because you really, first of all, you really know when something works on your CV. You can trust that it works on the LB because we had really perfect correlation. And it also allows you to not have this stress each day about using your 5 submissions, because you need to test some idea if it also works on the public LB. So for a few weeks we didn't submit at all, and we just, which is the first time we did it. I'm still not sure if it is psychologically for others more worse or I don't know. Yeah. And yeah, you can even, I mean, we could then even test if our correlation still holds by making our solution worse by, for example, changing the number of iterations of the model. You see the CV gets worse, you submit it and see, oh, it's worse again, the correlation holds. So that was really nice. And maybe one more thing regarding the solution, as Dmitry said, I think one main aspect was that you work with unordered entities and some relations between these entities, which in this case were mostly only speed and acceleration based relations between the players. So you had to find some kind of structure that works with these unordered sets and does not give any ordering, any arbitrary ordering. Because a simple thing most of us, I think, tried in the beginning is, okay, have a feature for each offensive player, which is the speed of the offensive player or the defensive players. But then you have to build a feature out of that in LightGBM or wherever. And you have to say, but you don't know, is now this player your first feature or this player your second feature? You can make some ordering by maybe sorting them by distance to the rusher, but this is all arbitrary and is not the solution that is warranted here. So that was quite novel. And there was another competition actually, which was very, very similar to that setting, which was who would believe about molecules. So that was the molecule competition about predicting the bonds between the molecules. And that had a very similar setup as tracking data in the NFL. You had unordered sets in some unordered entities in some space, and you had to find some relations between it. in that molecule competition, it was also mostly about transformers and graph neural networks, which work quite similarly. And in this case, in NFL competition, if you check the top leaderboard, out of the top 10, a lot of people also participated in the molecules competition. So that's also at one point when we saw that, we knew, okay, transformers are what all of them are doing, or graph neural networks. Of course, we also tried it, but we already had a different solution because we did not start with transformers. We started with convolutional neural networks. So not competing in the molecules competition might have been actually beneficial for us in this competition. We might have started with transformers otherwise.
Yeah, it gave us a clue at some point, and at some point we realized that we're competing with transformers. So we tried transformers on our own. We tried to even nicely incorporate them in our structure. So we tried both things. We saw that it works, but not as well as what we have. And that was another nice moment for us then, that we realized that we're on the right track.
Now, this is a question, I think it also touches upon a personal topic. What does it really take to win a Kaggle competition, if you could speak to that? Because I remember Philipp had shared that there was rescoring happening on the leaderboard and you were removed for a little while from the leaderboard, which I remember caused a lot of stress. My chai time neural net said you will win, even though back at that time. But if you could speak to both the personal and professional aspects of what it really takes to win a competition.
I don't know, mental stability. It was really, really stressful for us. I'm totally honest here, because we had the top solution. We were ahead on the public leaderboard by a wide margin. We knew our solution is super stable. There should be we cannot be overtaken basically on the private leaderboard. We were so sure. It was a two-stage competition, meaning it was rescored actually 4 times afterwards, because you cannot have the data, because you could crawl that data basically super easily, that you know how many yards that player rushed in that play. That's public data actually. So they had to do something, so they scored it on the actual new games, 4 weeks in a row. Of course, we were already nervous before. Then the first rescoring was published, which was a very bad timing. It was close to going to bed for getting up early to the flight to Tokyo, where we went to Kaggle days. And we were off the leaderboard. So we were really, really, really stressed. We tested our code multiple times. We ran simulations about the new data. We handled all null values. We even had a fallback solution in the kernel. So we had no idea why it failed. It turned out that it was a runtime error, most likely caused by, I still don't know the exact reason, but most likely caused because, as I said earlier, we tried to utilize all of the hardware we have available, and apparently they ran it on a slightly different hardware. So it failed. Thankfully, they figured it out. They kind of investigated it. They figured it out. Thanks to them a lot. So a week later, we were back on the leaderboard. Yeah, it was stressful. It was also stressful afterwards, because each time you think, oh, am I still on the leaderboard? Am I not? Christmas, both of our birthdays. So it was always a refreshing F5 checking, because I don't know, we were really invested in that competition. We were so excited about it, and it would have been a shame to be completely out of the competition by something like that.
Yeah,
it turned out everything went well in the end. So
yeah, thank you to the Kaggle team. Thank you to Will. I think he took over the investigation, and they discovered a certain bug in the batch process, so they fixed it, and we reappeared on the leaderboard, and that was a moment of relief.
Yeah.
With regards to what takes to win, Probably two things: believe in yourself and lots of time to spend on the competition. I would probably, people can use us as an example to prove that you don't have to rely on heavy hardware to win. That's for sure. So you can do really smart things with even with the hardware provided by Kaggle. That is in most cases sufficient. You just need to find a good idea, and just not to give up every time something doesn't work, some ideas doesn't work. Just keep trying, check what other people are doing, bring your own ideas, just keep doing until it works.
I think the message I'd also like to get across is it also takes a lot of personal sacrifices, not just in terms of time, but also since you've really put in these efforts, it also takes a mental barrier that you have to cross to win competitions. Now, Dmitry is already a grandmaster, and I know Philip is not a grandmaster yet because of your evil plan of keeping the name Zoo to yourself. But even as grandmasters, people that we really look up to as the knowledge keepers, was there anything that you learned away from this competition that you're taking away into your professional life or into your data science knowledge?
You mean from NFL competition?
Yes,
That
yes.
one in particular?
Yes.
Probably that was the point when we tried to be creative. So I wouldn't say we discovered something new to us in this competition. Maybe just tried out certain ideas and we saw that it worked. So my personal takeaway would be that was an experience to gain confidence in shaping up a neural network of your own structure. So I would be less resistant to like trying out certain things with neural networks in the future. So I can imagine myself like seeing either a pre-trained model or one built from scratch for a particular task, and then just thinking, oh, what if I remove this and reshape that and change the dimension over here? I tried, it fails, but at least I wouldn't feel that much of a barrier to try it out. I wouldn't feel stupid and unexperienced doing so anymore.
For example, in Apto's blindness competition, we also used neural networks, but there we used mostly pre-trained, predefined models. So we got first real confidence in using pre-trained models, fine-tuning them, and that kind of stuff. And this is the first competition where we really designed a neural network ourselves from scratch, basically. So I think we're much more confident to also do that in the future if some kind of problem comes up that warrants a more novel structure or kind of different setting of the structure towards solving the problem.
Okay. Now, before we end the interview, any best advices for both people just starting into machine learning and starting their Kaggle journey?
I think, as always, and can just repeat it, believe in yourself, don't be scared, do things, do things. This is not only fine-tuning the model, but this also goes back to building your code base, building your model. Like we talked about it earlier, copying a public kernel is fine, but you will never learn, because you said some people are scared to start from scratch. You will never learn it without actually trying it once. You can always go back to something, but at least try to set up your pipeline, because I believe it really helps you. There is so much information out nowadays. Don't be also scared by some titles. I mean, sure, that guy is a grandmaster, but he's also cooking with the same tools as you are. And there are several competitions, like the second place in the NFL competition is a quite unknown person on Kaggle, and he has done an amazing job and has crafted as a solo person a wonderful solution, which was the best transformer solution out of all. So don't be scared. Like, I signed up to the platform 7 years ago, and I would have never thought to be able to compete with the best here, because I never tried it and I never thought it's possible. But there shouldn't be some kind of too much worshipping, I believe, and being scared of people just because they have a higher title. Of course, they are all very brilliant people, but you can be yourself a brilliant person.
Even look at Santander, which was the largest competition Kaggle ever hosted so far. The top team consisted of 2 persons. One was a grandmaster, and the other one who put a lot of efforts in it had, I think, a novice title, basically. And that's what it takes. I do believe that there are a lot of people smarter than grandmasters out there, just not having enough time to invest or not yet having the practical Kaggle skills just because they need some time to gain them. And if you're just starting, you might be exactly the person of this profile. You just need time to maybe learn certain practical skills, maybe just get the mindset properly to approach the competitions.
Thank you for the transparent answers. Before we end the call, please could you mention what all social media platforms or any places where we can best follow your work? Maybe Philip, if you could mention yours.
You can follow me on Twitter, ph_singer. It's also linked on my Kaggle profile. Otherwise, as you mentioned, I'm a discussion guy on Kaggle, so you can follow my thoughts and complaints mostly also there. I'm in the typical Slack channels. You can find me there.
Dmitry?
Yeah. Same holds for me. I'm there on Twitter, LinkedIn, Kaggle. You can just text me on Kaggle. You get to my email address as well. I'm not posting as much as Philip does. I'm trying to get a little bit more into it. We'll see if it happens or not. But anyway, I'm open through multiple channels. Feel free to approach me.
Please steal Philip's memes. I'm sure those will be fun to check out on the forums. These links will also be there in the description of this podcast, so you can follow both of these people from there also. Thank you so much, Dmitry and Philip, for joining me on the podcast, and I hope to have you again once you win another competition really soon.
We'll try. Thank you for having us.
Thank you, Sanyam.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.